in your database or data warehouse. Okay.
Okay. Yeah.
So then we will go to the data modeling techniques. We have 6 different types of data modeling techniques. First one is entity relationship model. Second one is hierarchical data model. Next is network modeling technique. Next is relational data model. Next is object oriented modeling technique. Next is object relational data model. These are the different modeling techniques that are being used. And in the entity relationship modeling technique is you will first define the different entities. Suppose in a company you think like two attributes two attributes I will define was one was employee and another is manager. First you will define the different attributes or characteristics. I was just taking an example. So first you will restore the attributes in entity relationship modeling technique. Then you will decide the relationship between the two entities. What would be the relationship between the employee and manager? The relationship would be manager would be the boss of employee. So that would be the relation. So in this fashion, you model your data. First you define the attributes, then you will define the relationship
Really.
between them.
Yes.
This type of modeling technique is called entity relationship modeling technique.
Mhm.
Next is hierarchical. This is also called one-to-many kind of relationship.
Okay.
So this is how first you will have one thing at the top, and from that again some other attributes will derive, and again from that again another attributes will define. So if you take, suppose like I will take a single simple example. Just take like some supermarket, for example.
Mm.
Supermarket, pantry, and packaged food, like two sections you can have. So the common node would be the supermarket, or some restaurant you say, like if you take a restaurant, that would be the base node, and one would be dine in and other would be parcel section. So like that,
Mm.
if you see, in the similar way everything would get divided into different entities, and from one only, like many things would get divided in the sense the relationship would be built in that way from a single node. This type
Okay.
of modeling technique is called hierarchical modeling technique, and the most disadvantage is that if you delete something in the middle, like the total structure, like these childs also would get deleted.
Mm-hmm.
That would be the most, if you wanted to change something, that would be a problem in this model, because you don't know like the other things, this will become a parent, right, for these childs again. So
Yeah.
that is the main problem here. But it easily explains like real-time relationship, and it would be like easy kind of structure and easy to understand. But the main disadvantage is like in the middle, if you deleted, the child also will get deleted. So this type of modeling technique is called hierarchical modeling technique.
Okay.
So are you clear on this, or anyone wants me to
Yes.
explain again?
Clear for me, Surya.
Yeah, yeah, others.
It's clear, Priya.
Okay. The next one is network data model. Network data model also we can call as one to many and many to many and many to one
Mm.
also. So that's why it is network data modeling. So if I was trying the structure, you can see like you are having like one to many and many to many and many to one also. So network data modeling looks something like this actually. So you
Okay.
are defining one to many and many to many and many to one relationship here. The data is mainly arranged in a like graph like structure, we can say, and the
Mm-hmm.
child might have like multiple parent nodes here. But in hierarchical structure, if you see, the childs are having only a single parent node. Here you will
Yes.
have multiple parent nodes.
Okay. So what will be the advantage of this?
You can have like many relationships,
Okay.
in the sense like you can form the relationship between like different attributes here. That would be the advantage here.
Okay.
But here also the similar thing arises if you delete something like that which is connected to that will get deleted again. So
Yes.
that is also
Related
again
information will be
yeah.
deleted.
In hierarchical you can define only like from parent you can define only to childs.
Mm-hmm.
But here
Okay.
so if you say like from parent child and subchild is there, like from parent to
It is
subchild also
related.
like you can define relationship in network model.
Yes.
So that would be an advantage here in network model.
Okay.
The next is relational model. This is the one like mostly we would be using the database mostly, not always like, but today in today's world like mostly like 90% you can say like the relational model. Here in this relational model, the data would be stored in tables. So all attributes are or characteristics we will define here in the first row. So for each column you will be having the different attributes or characteristics you wanted to maintain. Suppose one attribute or characteristics for a business is employee ID, you think, and employee name, employee name, and his salary. You are just keeping. So what you are tracking the data or the characteristics what you are tracking for your business that would be in the first row. So that's like header of the and this vertical rows are like columns and horizontal are rows. So vertical things you will keep the characteristics like what you wanted to capture that you will write here, and what you are capturing that you will keep in each row, and that we say as a record or tuple in this model. So employee ID is one, employee name is Vishnu, and his salary is some 5,000. So such that you will enter all the records with respect to these attributes. And each row is called a record or a
Okay.
tuple. And the characteristics are column names.
Hmm.
This data model is called relational data model. Understood, or you want me to explain again?
Understood.
Once again, Surya.
Okay.
Once again, Shiva.
Yeah. You are just capturing the attributes or characteristics, right? Suppose for a business, your attributes or characteristics of data, what you wanted to capture for your business are employee ID, employee name, and salary. You consider like three attributes. Attributes are nothing but with respect to what you are capturing the data. You are understanding like when I say attribute or characteristic means you are understanding that point.
Yes.
Okay. So here, these are the three attributes with respect to which I wanted to capture data. So that I will keep as column names in this model. And the data, what I was capturing, I will write in each row. For first employee, I have written here. For the second employee also, I will write here. In the similar way, for all the all the employees existing in the organization, you are capturing the data with respect to your particular attributes. And each row, like what you are writing your data, is called a record. Okay.
Yes.
First, you understood the table, right? Table and relation. Then relation how it comes. I will explain next. This is table A. You think first you need to know this table. Table A. This is employee table. Next, there would be some department table. The department table also, you are capturing some data. Only two rows you are capturing, I think. Employee ID and department. So if you see here, employee 1 is working in HR department and employee 2 is working in a engineering department. Okay. So between between these two tables, there was some relation, right? You're establishing a relation and you are bringing these employees here and their department you are writing here. That was the relation. If you see, if you keep the two tables, then you will understand like 1 and 2 are working in this. One is working in HR department and another one working in engineering department. So that like you are forming a relation between the two tables. This type of modeling technique is called relational data model. Firstly, all the data would be stored in the tables and the relationship would be established between the tables. Are you clear? Hello?
Yes, Surya.
Yes, yes, Surya, clear.
Now you got it right? Okay, okay, good.
Yes.
Yeah.
Next is what? Next is object-oriented model. With you will define the object with respect to a particular objective. You will build the database. That is called object-oriented database model. Just I will think. In the object oriented data model, their relations are are referred to the object in this data model in a single structure, you can say. Like here in this single one, like he was a person. In this table, like you will write person, person name, age, and he can be a student or a doctor or an engineer that you wanted to capture. First you say like student, and here with respect to student or doctor or engineer, you can capture again data. What data you can capture? For student, you will capture, you can capture roll number or branch. For doctor, doctor ID and specialization. And for engineer, you can capture some ID and again department. So I understood this data model, or want me to explain again? Like here, from a single perspective, sir, or like everything would be contained, everything would be contained in a single structure, and also like you can define multiple relationships.
Okay, but in what basis they are connecting with each other?
Here, everyone is a person, right?
Hmm.
Again, person, you are defining only three things. I have mentioned here, but you can have like n number
Hmm.
of things, right?
Hmm.
And again, you will capture for each and every node. You can capture data.
So
Like in
the
real
roll number
world, you
and
can
student.
in real world you can just represent like everything as objects, like with different attributes. This is the real world, you think so? For each,
Okay, so my question is that roll number and branch is the child node of student. Am I right?
yes, these are again
So,
attributes of the objects.
okay. So is
This is
it
some
like
real
hierarchy?
world, like common real person is a just generalized thing, but from there, like again you can have different objects, and for that objects again you can capture like different attributes.
Okay, same lies hierarchical model, I think it is.
Yeah, similar to, but here it is a different kind, right? Here you are generalizing the thing, and from here this is some real world scenario. Some what do you say? Person is generalized thing, right?
Mm-hmm.
From person again you are deriving whether he is a student or a doctor or an engineer or a lawyer. You are deriving, and for that each object. So these all things are again objects derived from this person. These are not attributes of a person. Understand the point?
Okay.
These are the objects of the person, and from that objects, for each object again you are making the attributes. This would be better like for real world, you can say, because you can just generalize scenario you can have, and again you can split two objects, and again from there, like for each object you can capture attributes. But based for real world situations only, if you wanted to model it, they will use this one, or else they won't use it.
Okay.
Another example also you can take. So I think if I explain that, it would be clear for you. Wait, I will take other example. Again, generalized thing I wanted to take as a some shape. Define, you only tell me like some objects from the generalized shape that would arise. Just tell the objects that we can arrive from the shape.
Shape means